Let's start. We'll go to this workshop in which we will try to dig together in the details about the data space protocol and the different connectors that currently are available for the IDS standards, and then we like to try to find the main challenge that we have in the project regarding these topics, and we will try to go together over some solution, or at least through some ideas about how to go over it. So the agenda for this meeting is we will start with the goals of the workshop. That is the current section that we are going. We will spend no more than 5 minutes on that. Then we will take the help of Christophe to go over the current state of the art of the DSP usage, the data space protocol, and we check also the different connectors that are in place. Then we will see a demo, a demo for the connector. We will see a data change between two connectors, and that this will be led by Eviden. Maxine is who will make this demo. And then the most important part of this session is the discussion about the different challenge specific to ODEON that we will have during this project. Okay. About the goals of the workshop, okay, the main objectives of this workshop is go deeper in the current state of the art of the DSP, the data space protocol, and the available connector implementation, to discuss how they can fit in the specific requirements of ODEON. Okay, this is the main topic that we had. We will cover some point that what existing connectors are in use and the maturity level. In this point, we will provide insight into the types of connectors that are already integrated, and we could evaluate the robustness and the maturity level in order to decide what is the best idea here, and taking into account the compatibility with other projects. What are the connectors that are more used in other projects in order to assure the potential compatibility in the future for this project with others, and the scalability of that. Then we will review what data planes are currently available, the HTTP data exchange, that is the most popular, and if there is other data planes that could be integrated in that project, because they are moving forward in the state of the art, and they are being developed. We will see how the current identity management works, what are the main requirements of the identity management inside the IDS standard, and the solution that we will have for this topic. Then, as I introduced in the agenda, we will see a concrete example of the IDS connector usage. We will make a short demonstration of a real-world use case in order to give a practical understanding about how this component works, and where the data is, how the data is moving through the connector, what we can expect of this kind of component, like the data exchange connector. Sorry? Sorry, I'm not sure if you are asking or there is an open mic.
Looks like an open mic, yeah, which is closed now. Yeah.
Okay, and like the as last point, okay, using this common understanding that we will have about what is the connector, what are the different data space protocol, what are the different kind of connectors, how it works. Then, using this common understanding, we can go together over the specific challenge in the project in ODEON, and we can discuss about the best solution or ideas that we can have in this topic. And finally, the most important point, I think, that is map each challenge to a specific task that can be accomplished in the coming weeks, or to be sure that the project will run smoothly till the end. All this taking into account this topic. And that's all. That's the intro. I say then we will continue with the help of Christoph about the current state of the art of the data stream protocol and the different type of connectors. Thank you.
Yeah, thank you, Sergio, for the lead-in. I hope you all agree to the agenda and the goal of our workshop. In case you think we should reshape something or add things to the agenda, either let us know now, or also I think the biggest part hopefully will be the discussion. I also try to be quick with my presentation so that we have enough time to dive into the practicalities of things. Let me try to share my screen.
Yeah, I will stop.
So that you can see my slides. Perfect. Okay, so I already gave you a very quick run through during our meeting in Spain last time. Let me try to be a bit more precise on some of the aspects. On other things, especially when it comes to motivation, I think we can be a bit quicker, even though I included it here in the slides also for your reference afterwards. If you feel like you would like to reassure yourself why it's useful to make use of the data space protocol, you also will find this in the slide deck that I will share with all of us afterwards. In general, that was a slide I showed last time as well, the basic setup of a data space from the perspective of which components does the data space consist of. This also did not change since quite some time. There might be some changes, especially in wording. So I know that there is a lot of confusion, especially for those of you who are aware of Gaia-X, that the term clearinghouse is also something that is heavily used by Gaia-X, because the Gaia-X digital clearinghouse is one of the main assets, you could say, Gaia-X is providing. In cases of this, we are also considering to change our wording, because actually, if you have a look what these different components provide, you will find that there is actually no conflict, and it's basically something that can be seen as an addition to the entire setup of data spaces. But I'm not here today to talk about the different components. I just want to again point us to the two main parts in a data space from a user perspective, especially, which is the participants who provide data or consume data in a one-on-one data sharing process, which happens enabled by connectors. And I say enabled because the actual payload, that is also something we will see in some later slides, is not forced to be done via or go via the connectors. The connectors at this point in time are rather the environment in which the data space protocol helps you as participant of a data space to negotiate. What that means is something we will look in a bit later. As you can see here, also again, left side and right side, two connectors in the control plane, negotiating about what kind of data will be shared, under which conditions. Do both parties agree that the identity that the other participant has is trustworthy and is also on a level of trust to reassure the provider, especially to provide the data to the consumer side. Whereas the data plane, where the payload flows or the payload is exchanged or shared, can happen basically via any mechanism. I'm always taking the extreme example of the two parties via the protocol agree to share the data via an USB stick that goes to the mail, which is of course not making too much sense, but shows you that both planes are very decoupled, and you can, which would be a bit more realistic, also agree on sharing the data via any kind of cloud storage that both parties might use or have access to, given the fact that both agree and create a contract for the data sharing. Try to fix here. Yeah, okay. So what is the data space protocol? In a nutshell, the data space protocol enables you to stay sovereign of your data. It provides you with a certain level of interoperability, which levels this refers to, I can show you in a moment. It helps you to be scalable due to the interactivity with other data space protocol users. This is also something that with the adoption of the protocol also helps you to scale, since a fundamental level of interaction is always assured in case you use the protocol, and it helps you to be more trustworthy. And this is relevant because so each circle is one data space. Even within a data space, you can end up in situations where you're able to interact and negotiate, but the data actually is not shared, or the terms and conditions under which the data could be shared are unclear, which leads to conflicts. This is something where the protocol helps because it standardizes the understanding about terms and conditions, the policies, and the negotiation process, creating a level of interoperability, which we call intra data space interoperability, but also the interoperability between different instantiations of data spaces. So ODEON might have its data space. There are other data spaces also for the domain of energy out there, or even beyond the energy sector, which ideally would be interoperable. That's also something that the protocol enables. And as an example, let me switch to the next slide, which talks about this in a bit more detail, but I will go through this quickly. Just the motivation why standardization of protocols is so important, with the examples of HTTP, SWIFT, Bluetooth, or GSM, all for different sectors and purposes, but also imagining the times before those protocols were established and used as a standard. A lot of non-compatible communication was happening, leading to certain difficulties, which also is basically the state of play in data spaces right now, before the data space protocol actually becomes an official ISO standard, which is the case this year. Again, in a nutshell, the four aspects why the data space protocol is essential: sovereignty, interoperability, scalability, and the foundation on a technical and semantic level that leads to interoperability that is required for the exchange of data and the sharing of data. Another aspect, if you would like to also see it from the legislation part, so European policy making, the Data Act itself also brings a great motivation to the table why the protocol is important, because in Article 33, the Data Act asks for interoperability, machine-readable formats, APIs that enable you to share in an automated way data on real time and also bulk access. The protocol, as I try to motivate for you, is the answer to these aspects, as well as in the governance sector with smart contracts, because the outcome of a negotiation process based on the data space protocol is a contract that both parties agree upon, which you could interpret as a smart contract. Harmonized standards is something where we, from the protocol perspective, are aligning with different standardization bodies like W3C or ISO, but also with other initiatives like Gaia. This is something where we are collaborating closely to either create standards that are about the protocol itself directly, or like in case for the Sensenelec standardization efforts, we are trying to stay close to the definitions that are made on the topic of data ecosystems. I said interoperability is something that the protocol provides. To be more precise here, the interoperability that the protocol addresses, if you lay over the European interoperability framework, as you can see it here, the protocol addresses the technical and the semantical level, whereas the general framework also includes the need for organizational and legal interoperability, which is something that is not directly addressed by the data space protocol and rather sits on top of it, and also depends on national or geographical lawmaking and other aspects that the protocol itself does not solve, but at the same time, due to the mechanisms the protocol brings to the table, it at least is the vehicle, so to say, to establish policies, for instance, that are specific for local markets, where also parties which are sitting in different parts of the world can negotiate based on these local policies. In more depth, the protocol on the technical interoperability level provides you the aspect of standardized connectors. So the connector as the vehicle on the control plane that allows you to speak data space protocol, so to say, is a fundamental aspect. Also policy enforcement. So the data space protocol is based on ODRL, with which you can define the so-called usage policy, so the rules and conditions that either come from you as a company or that you're obliged to enforce due to your location in which you operate, and also the transfer process agreement. So what I took as an example with the USB stick, or also the cloud systems. Within this technical interoperability, the protocol allows you to agree on the way the data actually will be shared. Then on semantic level, just quickly, so the protocol is based on common data models. So you see here, JSON, LD, and RDF are the foundation for for the protocol. So the provider and the consumer can base on the same infrastructure. Also, the metadata standards that are used, in this case, DCAT, are defined, but there is a certain point where the protocol leaves it to you as a participant in the data space or also the data space ecosystem itself to define the domain-specific ontologies or models that are used to actually describe the data. The protocol itself just leaves you with a certain structure that is on a general level. And the domain specifics then can be hooked into the protocol structure. So also something you can negotiate about, but the protocol does not force you in any specific models when it comes to the domain specifics. I think I also showed this quickly last time. So who was co-defining this protocol? It's something that is not created so directly by IDSA. We as an association are relying on the work of our members and close partners. And in this case, you see here a list of those companies who were driving the effort of creating the right specifications and moving this the work, especially when it comes to standardization, to the Eclipse Foundation. And on the right-hand side, you see examples of projects, initiatives, and companies which are already using the data space protocol or commit themselves to do this once it is an official ISO standard. From an R&D project perspective, we also have a bunch of R&D projects that are already making use of the protocol. One is a project that I would like to highlight specifically because I'm discussing with our IDSA, my IDSA colleague who is responsible for this project, which is called Agri-Data Value. They are more or less in the same situation as we as ODEON. So they have a bunch of pilots. I think in their case, it's even more than the pilots that we have as ODEON. I think around about 20 pilots that they are putting to life. And they also are discussing about this aspect of interoperability within the project and beyond. And since they are lacking a concrete project, a concrete data space, which is up and running out there to connect with. The first level of decision they made was to set up a virtual data space or an instantiation of just another data space by themselves in order to prove this aspect of inter-data space interoperability. Since we as ODEON are running in the same situation, but this is something we probably want to discuss later, we either could decide to go the same path or to also collaborate with projects like Agri-Data Value, which are in search for counterparts. In this case, it would be even cross-domain, so two data spaces from different domains, which could be proving that they are interoperable to a certain extent. I'm not talking about semantic interoperability that agri-data and energy data are perfectly matchable, but at least to get to the point where two participants of each data space can come to an agreement that data could be shared. That's an offering that this project currently is thinking about. So from their side towards ODEON, and the other way around, we could also think about making use of this situation to have a counterpart with which we can prove the inter-data space interoperability later on. I included also a slide from their project to work a bit upon. So I think that would be a blueprint where we could say, okay, we as ODEON would agree to try to match each other's participants from a domain agnostic perspective, because we as ODEON will never speak agri-specific languages. So I think here we could make a clear cut to say, okay, we enable or we showcase the interoperability to a certain level, which probably will also lead to a situation where two parties will not share the data because they don't understand the actual payload. But for the sake of showcasing the general possibility of being interoperable, I think that would be an option that I wanted to just share with you to see in the discussion later on how we handle this aspect. So looking also to the clock, I think I will go a bit quicker now. So this would go a bit more in depth to see how the protocol is working internally. So we have this aspect of cataloging. So what kind of offering is available from a participant? Then this contract negotiation part where policies are defined as a first step, and then agreed or disagreed upon in a second step once you are in an interaction with a second participant. And then the actual transfer, depending on the agreements that are made in the digital contract, that is the outcome of the protocol negotiation. What we could use maybe for the later discussion is this here as a concrete example, just to let all of us know that this is there. We could go through this in a bit more detail to see how we from the ODEON perspective would fill such an example. So what would be the actual content in the cataloging phase? What would be the actual content in the contract negotiation phase? Like when does a contract start or end? Yeah, we could fill this with live that reflects the actual state of ODEON. And then the transfer process with the agreements, how the actual transfer works. So where does the data come from, where does it go to, what is the actual method. In this case, it would be a transfer via an IDS connector, but I hope I made clear that this is not really necessary. We also can decide for any other kind of transfer, and so on and so forth. So that's a blueprint, so to say, with a concrete example that we also can fill for our cases. Just for reference, because I also said, and you might have heard about this, the data space protocol is brought to ISO standardization via the Eclipse Foundation. Therefore, what I brought here is basically the specification process of Eclipse, of which IDSA and the community with the parties that I showed you on the slide with the logos before is part of, where our part was to write down and define the specifications. And now the technical artifacts and also the process for release reviewing and the rigid structure, also saying what is required in order to standardize the protocol within ISO, comes from the Eclipse Foundation. So it requires the specification document as one part, technical artifacts, so reference implementation, so to say, as a second aspect, and then the test and conformancy kit with which every other implementation that claims to be based on the protocol can check how close this statement is to reality, is the third pillar of this standardization process. And once these three parts are at hand, the standardization in ISO can proceed. Here, also for reference, the different Eclipse sources, so the specification as it landed in the Eclipse Foundation, Eclipse Data Space Protocol with a lot of specifications, and on the other hand side, the also latest state of play regarding the Eclipse Data Space test and conformancy kit that is required, which is something that is not 100% finished as of my state of knowledge, but is proceeding and will be available quite soon, because as it is a required pillar for the ISO standardization, it's also something that we're ensuring is there in time in order to stay true to the deadline to come up with the data space protocol as an ISO standard throughout this year. Quickly, a second teaser, because I don't know if we really have to go deep into this, but the agenda pointed out that I also want to provide you with an overview over existing connectors. First, so why just quickly, I first will show you the connector report, which we are frequently updating. The latest version has more than 30 pointers to existing connectors out there. But I think since within ODEON, we already have a partner who is dedicated to the job of caring about providing connectors, providing the right infrastructure, setting all partners that are making use of the protocol up with the right infrastructure. We also will have to see what is the partner capable of and can provide in this time. Maybe already Suit 5 in this case has some experiences with other projects. Nevertheless, I wanted to show you the big picture so that also we have an open field for discussions and do not have the feeling that we are bound to any kind of solution due to whatsoever reason ever. The field is there, but I also will tell you that this narrows down quite quickly the more serious you will take it. So data space connector or data connector report is available online. You can find the PDF document following the clickable link once I provide you the slides, or also scanning this QR code since I provide the slides afterwards. Don't worry about scanning it right now. It is structured as follows. So a first introduction, basically following the narrative that I was telling you now before. So why are connectors important? control plane, data plane, etc. What is the general structure of data spaces? Then it shows you the different implementations of connectors. Oh yeah, it's 35 data connectors which are listed in this report right now. And as you can see, each connector comes also with a profile where you can dive a bit deeper into the specifics of each connector to see where it comes from, which are the partners who are contributing to it, where is it used, what kind of technical baseline is used in this connector, etc. Then we also have a list of additional initiatives and promising emerging solutions, how we called it, to also be able to point to things like ocean providers, which comes from the Ocean Protocol initiative, I think, to make some connections also to alternative solutions to the protocol. Also, the GaiaX Trust Framework is something that, so I did not bring this tech architecture slide, but there is a certain architectural stack that also makes clear that data spaces do not consist only of connectors or the components that I showed you in the dark slide at the very beginning. It's actually an entire stack that starts with infrastructure like cloud to edge infrastructure, and then works itself up all the way to the use. That's probably something that we want to discuss, the use cases. But in the middle and in between these two extremes, from bottom to top, you also encounter identity discussions. You encounter GaiaX Trust Framework as example for trust infrastructure, etc. pp. So that's also something that is depicted here in this report in a quick conclusion. Yeah, this would be already a tree. So working yourself from the list of 34 connectors, trying to bring in some structure to help to make a decision. As you can see here, even though it's 34 connectors, actually we are just dealing with roughly 5 categories, where of course one is any other implementation, but you could say the connectors with the most activities around that we are observing are the Eclipse Data Space Components connector, the data space connector, which is historically still relevant, but a bit older. Then we have an instantiation by TNO, the Dutch research institution, which is also used in some examples, and the so-called True Connector. I think it was implemented by engineering from Italy, and then found its home in the open source community of the Fireware Foundation. And there are certain other, I would not even say smaller data space connectors, but some which stand on its own at this point. As you can see here for the other examples, there are for frameworks like the EDC connector framework, several examples of implementations that were driven forward by different partners. So Solvity, a small startup, is using this. Then Silicon Economy is a Fraunhofer-driven project that is using EDC. HealthX, a health data space. Telekom Germany is basing their data space offering on this. Mitsubishi Electric, Huawei, EON-IX, a mobility data space, and SAP. These are partners that are making use of this framework to use or provide connectors on their own. Same or comparable lists also for the data space connector, which is a bit older. And then it gets a bit smaller for TNO and the True Connector. And here, like I said, smaller instantiations of projects that stand basically on their own. Yeah, that also was my last slide with this connector overview. Either we go into a quick round of questions already that might have queued up, or I hand over to finalize the presentation part, which now would go into some more practicalities. I would leave it up to you. So feel free to raise your hand in case you have comments. Or I don't know, Maxime, how you would feel comfortable if you just would like to proceed based on what I presented now. I'll leave it up to all of us.
Sure. I mean, both approaches are fine for me. I think it will flow naturally not to have the demo. So thanks a lot, Christophe, for your presentation. Maybe just to probe a little bit the audience, we can see, does someone has any question at this stage I would like to raise?
Doesn't seem to be the case. So then let's proceed and take it then later in the discussions.
Okay, perfect. Okay, then I will share my screen. Oh, you should all be able to see my screen now. Is it the case?
Yes.
Yeah.
Okay.
The desktop. Thanks. Yeah. No, it's this is
exactly. Thanks. That's the goal. I'm trying to share the full desktop, not only the slide, because the idea I just keep that slide extremely quickly. It won't be slide heavy. I will focus on the demo itself. It's just this slide is just to introduce like what we will see actually in this demo. So I think you're familiar with this type of graph now. Christophe showed you like what was the principle of data space connector, and one of its very first slides show you like the full ecosystem. So this is a stripped down version where I focused only on two connectors and how they exchange data. So as you can see, the idea here is fairly simple. What we will see in the demo is two different connectors hosted in two different premises. For the detail, they will be hosted both in a Kubernetes cluster. And so one will play the role of a provider of a data set that's hosted in a remote data source, and the other will play the role of the consumer who is interested in getting that data set, and so it will store the downloaded data in its data sink on its own premises, or actually on the remote sources. If we have time, we'll see both. And in between the two, obviously, there will be an identity system. I won't go into the detail of this. I won't show that, but just know that to make that transfer possible, those two connectors are registered in a common identity system. And so let's get started and get our hands a bit dirty. So what I will use for this are the connector provided by Soviti that was quickly mentioned in actually the last slides also of Christophe. So that's a fork of the Eclipse data space connector. Okay, so there we go. So here, basically, don't mind all my tabs. My two instances of the connector are hosted in those two different domains here. So just to prove you that they are different, I'm just using the web UI that Soviti implemented on top of the connector that makes it very convenient to use. I won't spend time in the dashboard. My goal is not to do like a full presentation of how that connector works. And especially how its UI work. It's just to show you like how the transfer works in practice. So the very first step you'll go through in that case is to create a data offer. So the idea of creating your data offer, like split that in two parts. One part refers to what's called an asset. And an asset is basically like a description of your data in several ways. So we will create one together. For instance, let's say that what I want to provide is a data set. Like let's take another one actually. In that case, I think. Yeah, let me go for this one. So this is a data set. Sorry for the formatting. It's not really, this is just the top 20 of of the richest people on the planet. Let's say you want to share that as a data set, and this is just hosted on Pastebin so far, but that would not change anything if it were on your premises on a web server or so on. Let's say that's what you want to share. So the first thing is to create the asset that corresponds to this data set. So for this, basically, what I'll do is that, okay, I will say that you can query that asset through like a REST API endpoint with a get method, no problem. I will put the URL. You can, if you want, put some parameterization. For instance, if you want the path to be parameterizable, add some query parameters. So a body, whatever, because you can change that method. Some of those things are specific to the Sovity connector, though. So keep that in mind. That what you want to put here, what type of data you want to share, strongly depends on the connector implementation you use. Now, after I just gave like where my data is located, it's time to fill in some metadata. So, like for instance, here, like as a title, let's call that top 20 billionaires, and ideally to spell that correctly. And then you can put like any kind of description you want here. That's not that. Let's keep on that. Same here. You can put some keywords to refine your description and make it useful in a catalog search. And there are a few other fields that you can put: a version, language. Again, some of these could be specific to your implementation or the semantics that you use in your project. And then, so this actually covers what the asset is. That's what a data asset here is. Here in this publishing, basically, we are dealing with the policy part. So we want to make that available on this asset available on the data space. Now we can add some ODEON policies to rule or this offering can be accessed by other participants in the data space. So this, again, this is Sovity specific in their UI. This unrestricted just will create under the hood a policy that said that anyone at any time can access this. Now if I put a publish restricted, for instance, just keep under the hood that those policies are written in ODR. So it's also up to you in your implementation to support whatever policies you want and to create whatever tool you want to make that more convenient to create those policies. So for instance, here Sovity implemented something where you can list some participants' ID. So this means that the ID is to restrict the access of your offering to a given set of participants within your data space. But here, for instance, in our case, let's take a time span restriction. So we just say, for instance, we want this to be accessible for the month of February. Okay, that's this means that in March your offering won't be accessible anymore to the people in the data space. So it creates it. Fine. Let me minimize this so I can see the button. And now if I hit publish, I see that in my list of assets I have this top 20 billionaires that appear, and there would be all the metadata that I put for this. If I go to the policy, it also created the top 20 billionaire that corresponds to that time restriction. I won't go into the detail of this, but the idea of this separation between asset and policies, because obviously you can reuse your policies across a given set of assets. I could have just created a policy separately saying, I want this to be available this year or this month, and then we use it for several assets. Anyway, and now that I've created this, when I hit the publish button, it means that actually that offering is now available in my catalog. So here, for instance, when I go in this in the catalog browser, you can see I had other offerings that we created previously in my team, but the new one that I just created appears here. It's because right now this URL here or pass whatever other connector endpoint here to actually query their catalog. I'll do that, for instance, here. So if I pass the URL of the other catalog that I've hosted here, you see now it augmented this list because also their offering appears, not only mine. But yeah, anyway, let's now see that in practice. Let's try to see if the other participant can also see that that offering and actually negotiate a contract to acquire the data set it contains. So let me go to the other connector now. Actually, it's in its catalog browser. So you see actually the two offerings that were added where I paste its URL here. So now let's put here the URL of the connector in which I created the offering that you saw previously. And yeah, you see I can see all its offering, including this top 20 billionaires one that I just created. So now if I hit if I select this offering, I'm given the choice to negotiate it. So negotiate it meaning like creating a contract agreement that says that yeah, we are bounded to an agreement that will rule the data transfer and that will obey the policies that were defined in the contract. You can imagine that later on, there could be several steps in the negotiation. So far, when you click negotiate, upon accepting these terms of condition, which will be specific to your data space, that's up to you what you put in those terms and condition. And then in that case, it accepts this automatically because there's no such thing like a step of a pending approval or anything. Once you select that you want to negotiate the contract, if you were allowed to access this offering, this will always be successful. So from there, then you can go in the list of contracts. And here, I mean, I have a lot, I apologize for this. I've used this connector already extensively. You can separate your contract into categories. The contract that you're consuming, so from which you want to download the data sets, and the contract that you're providing. So now that you can see that in my consuming contract, I have this top 20 billionaire. It also conveniently in this UI tells you like how many times you decided to transfer the data set. So you can see that it's a pretty new contract. We haven't done any transfer yet. So now let's go to like the interesting part and check if we can acquire this data set. So for this, I just need to click transfer, and upon clicking transfer, what I need to provide to finalize this step is where do I want to put the data set. So where do I want my connector to end the data to? So basically here, very similar to when we created the offering, we need to give an endpoint. This time not to get the data, but to push them. So here, let's keep a REST API endpoint, but again, you can implement whatever you want in your connector to make it differently. And let's suppose, like for instance, here as an example, I will take. It will be visual, I think, if I start with taking a webhook. So let's suppose, like here, let me just actually refresh that page. So we have a different one, and I will copy this link. So basically, I will just use webhook to show you that this data set here will be modified and that the data about the billionaire will appear instead. So I just say, okay, put the data in those endpoints. Here again, you can configure whatever you want. If you want to dump that in your own database, which has an authentication layer, you can, and you can put some data for your authentication here. This is on the side of your connector. Obviously, the provider of the dataset won't know anything, and you can parameterize the request the way you want to make sure that it adapts to your data sync. And now, if you click Initiate Transfer, it should not actually take so long. You see, it's already done, and I can see that I have a new request here, and that corresponds. Like if you see the time, 9:53. Sorry, I'm in England. So you can see we received the data set that we are interested in. So all in all, we perform a successful transfer of the data. So and you can confirm that by here going in your transfer history and see that yeah, indeed, a minute ago you transferred the data from this connector. So I mean that's roughly it for me in terms of the demo. Again, I stayed extremely simple here. The goal was really just to show the transfer work. I just want to highlight that even with just supporting REST API endpoints, you can already do a lot. If I go back, for instance, to the creation of an asset, when you think about it, okay, this is very different here. So let me just do that. Here, nothing prevents you basically, instead of exposing a data set, to actually expose a full API. If your implementation supports that. You could perfectly enable here the parameterization and say, so like then your consumer can actually post something to your endpoint. So this could be very powerful if you want to, instead of exposing a data set, expose a full API where people can query any sub part of the data set that they want. And the last thing that I wanted to mention, that you don't have any restriction in terms of how many time you want to consume the data set. Again, if you want to create policies where you put such a restriction, this is up to you. But the only policy that we've put is a time restriction. So it means that until February 28th, I can download that data set as many times as I want. So anyway, that was roughly it for me for this demo.